Good morning, ladies and gentlemen. Thank you very much for joining us for the conference on reflections on the Minamata Convention on Mercury towards Mercury Management in the Global South by ERCA in ISAP 2023. Before opening, this is a housekeeping announcement. We have international audience, and for them we have simultaneous interpretation in Japanese and in English. And please refrain from taking pictures and screenshots and recording the session unless you have permissions. And please use the Q&A function on Zoom. We would like to receive your questions. And after 3 lectures, we would like to have the Q&A session. And if you don't mind, could you please write your name for the questions? Because of the time constraints, we might not be able to answer all the questions. Thank you for your understanding. After leaving Zoom, you can see the questionnaire screen. Could you please cooperate with us? So now, we'd like to start the conference on reflections on the Minamata Convention on Mercury towards Mercury Management in the Global South. So I'd like to invite Yoshinori Tanaka, the Director of ERCA, Environmental Restoration and Conservation Agency, to extend a few words. Good morning. My name is Yoshinori Tanaka, Director of the Environmental Restoration and Conservation Agency, Japan, ERCA. We are an independent administrative agency under the Ministry of the Environment and engaged in a wide range of activities, including compensations for the pollution, subsidies for environmental conservation conducted by the private sector, and relief for health hazards caused by asbestos. Among these, the Comprehensive Environmental Research Promotion Fund allocates approximately 5 billion yen annually to researchers to promote environmental research and technology development that contributes to environmental policies. Funds are provided for a variety of research and technology development, including climate change countermeasures, biodiversity conservation, and technologies for efficient recovery and regeneration of resources. Today's online meeting of ISAP 2023 will focus on mercury management. And also, we have technological development, and in some PT, we have Professor Takaoka as a speaker, and he has given us some assistance. Today's online meeting of ISAP 2023 will focus on mercury management, and we would like to introduce the result of the researches in Japan. The government officially confirmed Minamata disease in 1956. The government, local governments, industry, and civil society have been working on mercury control after experiencing enormous damage caused by methyl mercury. Environmental standards were set for water, soil, and air, and measures were taken to control emissions into the environment. Looking around the world, mercury is emitted from diverse sources, including ASGM, industrial applications such as vinyl chloride, dental amalgam, and coal combustion, and there is a global concern about the health effects. In response to this situation, in UNEP, the United Nations Environmental Program, in 2001, started discussions on heavy metal countermeasures, and also from 2013, for the protection of human health and the environment from anthropogenic emissions of mercury, they started discussions, and also the convention was adopted and entered into force in 2017. It stipulates proper management and reduction of emissions across the life cycle of mercury, from mining to distribution, use, and disposal, and it can be made more effective by examining the result and challenges from these measures. ASGM, artisanal, and small-scale gold mining, mainly conducted in developing countries, It's one of the most common forms of mercury use, yet it's poorly managed, so the challenge is to strengthen health hazard prevention through appropriate mercury management. Today's three speakers are researchers who have tackled these issues utilizing comprehensive fund for the promotion of environmental research, and their knowledge and research will lead to solutions to the problems I have just mentioned. I hope that today's lectures and discussions will help to manage the Minamata Convention more effective and further progress in the management of mercury in the world. I hope that all the participants today will actively participate in the session through Q&As. Thank you.
Thank you very much. Now we would like to begin the lecture part. The first, Professor Masaki Takaoka, professor from Kyoto University, is going to give us a presentation on past, present, and future of mercury problem. Let me share the screen. Can you see this okay? Yes. Thank you. Once again, good morning, everyone, and thank you very much for your introduction. I am Takaoka from Kyoto University. Very nice to meet you all. As has been introduced already, the title of my presentation is Past, Present, and Future of Mercury Problem. This is the outline of my presentation today. First, I would like to reflect upon the past and the current status of the mercury issue. And after that, I would like to talk about the Minamata Convention on Mercury, which entered into force in 2017, because this has formed the basis for tackling the current mercury issue. And after that, I will talk about the future prospects. As has been introduced already, we are getting some fund for comprehensive environmental research promotion that is funding a strategic research, and we are conducting a study out of that strategic research framework. And the fund is provided by ERCA, and today I'd like to present some of the research results. And finally, I will present my conclusions. First, let me review mercury again. Mercury has been used in our society since ancient times. According to the Nara period Todaiji Great Buddha record, 50 tons of mercury and 9 tons of gold were used to gild the Great Buddha. And if you look at a map of Japan, you will find many place names which include characters such as new, as you can see in these two examples. And this character is said to be related to the place of origin of mercury. There is also a shrine in Wakayama called Nyutsuhime Shrine, which is dedicated to the god of mercury. So all of these are representing how familiar mercury was as a substance. And mercury is also the only liquid metal at normal temperature and atmospheric pressure, making it extremely useful, and many products have used mercury. And these include dental amalgams, thermometers, and fluorescent lamps as shown in these pictures. On the other hand, mercury is highly toxic, and the Minamata disease, which you are all familiar with, occurred in the 1950s. And it was a severe pollution and caused enormous health damage, with 78 people dying out of 628 patients between 1953 and 1960. And in 1991, a government-affiliated study group compared the damage caused by the Minamata disease with the cost of pollution control measures. And this is assuming if appropriate pollution control measures had been implemented, how much damage would have been avoided. So in terms of the damage, the cost was 12.7 billion Japanese yen per year, and especially this includes health damage of 7.7 billion Japanese yen. So how much needed have been spent in order to avoid this kind of pollution? This is actually estimated. Is it the same amount, or is it just one half, or is it 1/10? Actually, the answer is it's only 123 million yen. It's just 1/100th, meaning that activities that prioritize economic development and neglect the environment can cause a variety of serious damage that is not easily remedied later on, including health damage. So this is a very important lesson we have learned from the Minamata disease. And later in the 1970s, cases of organic mercury poisoning in bread caused by mercury pesticides were reported in Iraq. But it was probably the mercury pollution and damage caused by gold mining in the Brazilian Amazon during the UN Rio conference that became widely known to the public. While these are localized cases of pollution, a large-scale epidemiological study of the health effects of low concentration of methylmercury ingestion via marine products was conducted in the Faroe and Seychelles Islands in the 1980s. The Rio UN conference, given the lesson learned from the Minamata disease, came up with a very important principle. And this is what is called Principle 15 in Rio Declaration. And it goes as follows. To protect the environment, the precautionary approach shall be widely applied by states according to their capabilities. Where there are threats of serious or irreversible damage, lack of full scientific certainty shall not be used as a reason for postponing cost-effective measures to prevent environmental degradation, which means that the importance of precautionary measures is stated here. And times have moved on for further, and based on these scientific findings, in 1997, the US EPA prepared a report on mercury, and they submitted the report to Congress for actions. And this included the scale of US mercury emissions by source, the health and environmental impacts of those emissions, and an assessment of the availability and cost of control technologies. And at the United Nations back in 2001, to promote action on mercury pollution on a global scale was decided, and the UN conducted the global mercury assessment. And this set the trend for an international regulatory framework for not just localized pollution, but also pollution at low concentrations and preventive measures. This one illustrates the global cycle of mercury cycle. About 2,200 tons of mercury was emitted into the atmosphere in 2015. It's around 2,500 tons between 2,000 to 3,000 tons every year. And the breakdown is shown in this pie chart. The highest emissions are from artisanal small-scale gold mining, or ASGM. And about this ASGM, the next speaker, Dr. Nakajima, will introduce in more detail. Also, globally, these are the sources of mercury. And the mercury is once stored in the atmosphere, and then mercury falls to the ground and the ocean. And partly mercury is taken up in the oceans, but as you can see in this orange, mercury is also re-released from the ground and from the oceans, which means that mercury is circulating. And in this cycle, bioaccumulation takes place and mercury can become concentrated in higher marine products, and the health risk of ingesting it is a problem. Therefore, as you can see, the Minamata Convention was created, and this started back in 2003 based on the assessment compiled in that year in the United Nations. And eventually in Kumamoto, there was a diplomatic conference, and this led to the adoption of the Minamata Convention in 2013. And this was the second treaty to be named after a Japanese place. And in August of 2017, after ratification reached 50 countries, Minamata Convention went into force. And right now, 128 countries have become the signatories to this treaty. And the purpose of the Minamata Convention is to protect human health and the environment from anthropogenic emissions of mercury. And this convention consists of 35 articles. And then these are the major ones: mercury sources and trade, products and manufacturing processes, products containing mercury or manufacturing processes using mercury, and artisanal small-scale gold mining, emissions and releases, storage, waste, and also contamination sites, and so on and so forth. The most recent conference of the parties to the Minamata Convention, COP5, took place last year in November. And their discussions were made, and a decision on products that are to be newly banned or restricted in use were decided. Examples include fluorescent lamps, batteries, dental amalgams, and so on and so forth. There are also discussions on the release of mercury into water and atmosphere, including the preparation of guidance. And one of the major outcomes of this COP5 was to set the standard at 15 milligram per kg. That is the total concentration of mercury and the threshold for wastes contaminated with mercury. And a national report is to be compiled, and the agreement was made to put together such national reports. So the Minamata Convention is worked on to be improved day by day. As I mentioned earlier, the Minamata Convention seeks to take measures by combining various technologies and systems, such as elimination of mercury in products, conversion of manufacturing processes, application of more advanced emission and release control technologies, and etc. But will the mercury problem be solved in the future if the agreements made by the Minamata Convention are observed? We don't know. So to consider the future situation, we need to consider social changes at the same time in implementing measures. We need to have a base scenario, and we need to have an intervention scenario which incorporates the effects of measures are necessary to evaluate the effectiveness of the measures. At present, it is difficult to quantitatively understand and evaluate the overall effects of individual measures. Therefore, to predict the future, we developed models. And from these models, we try and understand behavior under natural conditions and also anthropogenic activities. So we try and evaluate that with those models. As you can see on the right-hand side, this is looking at certain changes in mercury concentration in seafood. And based on this, we estimate the exposure and also damage on our human health. So this is something that our research team is working on, and I'd like to introduce to you some of the results out of our research. So first one is atmospheric mercury concentration. and also mercury concentration in ocean surface layers. So this is done by Dr. Takeuchi from the National Institute for Environmental Studies. And then 1850 is considered to be one. And then we estimated the concentration from 2010 to 2050. And of course, there is an effect of climate change being considered, and the scenario incorporates that understanding. As you can see, the red one is baseline, and the yellow one represents gradual reduction measures being taken. And the third one is a scenario with maximum reduction measures being implemented. So with measures implemented, you can reduce the concentration. But then with the gradual reduction scenario, you can't really see the reduction. This is still a little bit above the status quo. And from the outcome of the results of this research, we are looking at the benefits. And this is done by Dr. Hayashi of the National Institute for Environmental Studies. So WHO issues tolerable weekly intake. These values are exceeded by some population, and IQ reduction and cardiac deaths. These are considered to be very important indicators of the mercury impact. And also, given all of these indicators, the total economic costs are being estimated. And without any measures and with certain measures, in terms of WHO tolerable weekly intake values, how many population access these values, and this population can be reduced quite greatly with the measures being implemented. The IQ decline can be prevented, the number of cardiac deaths prevented is indicated here, and the total economic loss can also be reduced quite significantly. Next. I spoke about the estimation in the atmospheric concentration in the sea surface concentration. So with the reduction scenario and with the status quo scenario, what are the differences in terms of the concentrations? You see these colors, and if the colors are darker, this means the differences are bigger. And the difference of the concentration can actually indicate how effective the measures are. We need to monitor the effect in order to know that. And as you can see from these charts, the South Asia and Africa are the regions where we see quite big differences. And these are the areas we need to have the monitoring. And this way, we can measure the efficacy of the mercury measures in a more precise manner. And then finally, this research is done by my own research team, and this is looking at the mercury being element, and it cannot be broken down. So what happens is that the mercury cycle is being formed, and unless we break down this cycle, the mercury will just be circulated. So here we are looking at how to stably store the mercury. And we look at the reaction with sulfur, and then we create mercury sulfide. And then this can be solidified and stored as waste in landfill and elsewhere. So this is a kind of a method we have done research on. So I'd like to give you conclusions of my talk. First, we experienced Minamata disease in the past, and we learned the lesson. So if we prioritize economic development and neglect the environment, this can cause all sorts of serious damage, and this cannot be easily remedied later on. So this is a very important lesson learned, and this can apply to other environmental issues. And the future projections show that reducing anthropogenic mercury emission into the atmosphere, this can reduce global mercury concentrations in the atmosphere and surface seawater. But even with emission reduction measures such as those envisaged by the Minamata Convention, atmospheric mercury concentrations will only offset economic growth and remain at the current level. And without action, the economic losses due to health damage will increase by 2050. And it is also important to develop strategy to monitor mercury and store mercury in order to break down the mercury cycle. So the stories I have presented today are from my research and the research done by respected researchers as well. So I'd like to take this opportunity to thank the collaborators. So this concludes my presentation. Thank you very much for your kind attention. Thank you, Professor Takaoka.
So the next speaker is going to talk about mercury legacy, use, trade, and anthropogenic emission. Dr. Keiichi Nakajima, National Institute for Environmental Studies. Doctor, please. Thank you very much for the kind introduction. My name is Nakajima from the National Institute for Environmental Studies, Japan. Humanity has enjoyed many benefits from the use of resources, but some substances must be eliminated from use and managed in isolation because of the toxicity. Mercury is one of them. This is toxic and can cause serious damages, can be disposed of unnoticed, and also allows metal extraction by anyone, making immediate action essential. COP5 has recently concluded, and I would like to introduce some of the research that our group has conducted for S26 to provide information for considering mercury management. Humanity is said to be facing a triple crisis: climate change, biodiversity loss, and pollution. Recently, there has been much discussion about the effects of climate change on the ecosystem and human health, and we believe that mercury is another issue that humanity must address with the collective wisdom. The key word today, one of them, is secondary impact. Sometimes countermeasures to one problem have synergistic and co-beneficial effects as positive secondary effects, but sometimes a countermeasure leads to another problem as a negative secondary effect. We're beginning to understand that such events can occur in mercury control as well. In order to realize the health of the global environment and human activities, we believe it's necessary to identify potential problems before they occur and take appropriate measures based on life cycle approach. So where is mercury used and emitted? This is UNEP's estimate. In 2017, there was a demand for about 4,715 tons of mercury. As Professor Takaoka said, mercury is a metal that is in a liquid state at room temperature and forms an amalgam that melts when other metals such as gold are brought into close proximity. This feature is used for gold extraction in ASGM and the other industries. In addition, mercury is also used in industrial applications utilizing catalytic reactions and in manufacturing of mercury-containing products such as lighting and measuring equipment. On the other hand, looking at emissions, ASGM is still the largest emitter, followed by fuel consumption, combustion cement, and non-ferrous metal production. In fact, it has been pointed out that fuels such as coal and some mineral resources contain trace amounts of mercury, and since mercury is generated through combustion and other high-temperature processes, even sectors that do not intentionally use mercury emit significant amount of mercury. By region, emissions from Latin America and Africa are second only to those from Asia. Closely related to emissions in the Latin America and African regions, or in some parts of Asia, is ASGM, one of the main sources of mercury pollution. Its production scale is said to be about 15 to 20% of the world's gold production. There are also indications that gold mining in ASGM, as well as a number of other issues, are becoming more serious due to the recent surge in the price of gold. Environmental contamination by mercury and health effects on women and children, including pregnant women, being engaged in this work amid concerns about exposure to mercury Furthermore, it has been pointed out that ASGM has many illegal and improper operations, as well as many unfair working conditions, including child labor and modern slavery. Gold is indispensable for electronic circuits, essential for automobiles and electrical and electronic equipment control. So it's easy to imagine that this issue will be closely related to the realization of decarbonized society and advanced information to support it. So how do you think future mercury emissions will change? There have been several studies in the past that quantify future scenarios of mercury emissions. There are also studies that has assessed the impact on human health. However, these studies that address future estimates do not adequately take into account both climate action and implementation of the Minamata Convention. The expansion and scrutiny of these social scenarios is essential for future estimation, especially given the rapid development of decarbonization effort and the potential impact on the mercury cycle. This is where this study has an advantage. This estimate includes 32 country and region categories covering the entire world. However, due to time constraints, we will not explain detailed trends by country and region today. In addition to BAT and BEP, at the source of mercury emissions, reducing coal consumption and decarbonization industrial processes such as steelmaking can also contribute to reducing mercury emissions from raw fuel sources. So in our analysis, we evaluated a reference scenario that assumes technology fixation and likely outcome, and 3 types of mercury reduction scenarios, 2 types of decarbonization scenarios, and the combination of both of these scenarios. And this is the result. This shows the continuation of the current method, and this is the reference scenario, and this compare the reduction effects. It's clear that the introduction of mercury countermeasures can be expected to significantly reduce mercury emissions compared to the case where there is no additional measures. However, under the A1 phase-out scenario, reductions would only offset the increase in emissions associated with economic growth after 2015, indicating that the immediate introduction of maximum mercury control is required. And this phased reduction scenario is an expert judge scenario developed on interviews. In addition, calculation of the co-benefit effects of decarbonization measures together with mercury control showed that a considerable amount of additional reduction is possible, but we have found out that there are some secondary concerns. I will discuss this later. So this is a breakdown of emission source. In the absence of additional measures, emissions from mining sector such as ASGM and other mining, metal mining, cement industry, and the power generation sector would increase significantly. And also, the sources of emissions by country and region were mainly in the African region, China, India. On the other hand, if you assume that all countries and regions should reach the highest level of technology currently implemented by 2050, more reductions can be expected. This suggests that each country, including Japan, still has significant reduction potential. This is a breakdown of emissions by country and region and the source of emissions under the phase-out scenario. The analysis also revealed that emission trends and reductions are unevenly distributed across regions. To minimize mercury emissions, it's essential to further strengthen measures in sectors with remaining emissions in especially China, India, South America, and Africa. In particular, it's essential to introduce support, monitor, and control ASGM, a major source in Africa and South America, as soon as possible. As mentioned before, the introduction of decarbonization measures corresponding to 2 degrees or 1.5 degrees scenario can be expected to reduce atmospheric emissions of mercury through co-benefits. By looking at the global mercury emission pathway for the 1.5 degree target equivalent scenario in the figure on the right, the decreasing trend until 2040 will turn to an increasing trend after that. This was found to be mainly due to emissions derived from biomass combustion in the power generation sector. So if biomass power generation increases as a decarbonization measure, we should need some cautions and verifications because it may increase mercury emission. As the largest user and emitter of mercury, according to the convention, ASGM should reduce and, where possible, eliminate mercury use. So we calculated the effects of the introduction of 3 types of mercury control: emission control by use of retorts, use control by the concentrating method, elimination of use by cyanidation, as well as the possible secondary effects. In addition, to assess the economic feasibility of the measures, we calculated the cost of sequestering and managing the recovered waste mercury. The analysis revealed that while a combined retort concentrator process or conversion to cyanidation can significantly reduce mercury emissions, it can also increase enormous cost for permanent proper management of recovered waste mercury and new health risks because of hydrogen cyanides. Inadequate measures may cause distortions that cast a shadow over society, the economy, and the environment. I believe that further international cooperation is needed, including the review of countermeasures. These results are presented in detail in the paper. Please read it sometime later. The use of information inconsistency is today's second keyword. ASGM is one of the major sources of emissions and requires immediate attention. Mercury related to ASGM has a problem of illegal trade. As the Bali Declaration of COP 4.2 reiterated the importance of international cooperation in addressing the illicit trade in mercury, this is a very important issue to eliminate mercury use. Some experts, however, also point out that increased illegal distribution of mercury has increased, along with the strengthening of mercury control since before the convention, making it even more difficult to grasp the situation. Our group has worked to design and develop 2 types of analytical methods for detecting improper distribution with a view to assisting in addressing illegal trade. Both are unique methods in that they take advantage of inconsistencies in statistics and other reported values. As you know, Article 22 of the Minamata Convention specifies the implementation of effectiveness assessment by the parties. The draft also includes indicators for trade. However, it says in accordance with. The draft only covers trade based on import-export agreements and has no way to identify illegal trade, which can be considered a bottleneck. We believe that the method we have developed takes advantage of inconsistencies in information to challenge these bottlenecks. The first method is to compare the amount of mercury used in ASGM for each country with the apparent consumption of mercury for the country as a whole. The former was calculated based on gold production and mercury utilization intensity in the ASGM. The latter, on the other hand, was calculated based on mining and trade statistics. Basically, the apparent consumption figure is larger including the amount of mercury associated with all industrial activities. But as a result of the analysis, significant inconsistencies in the reported values of mercury consumption and use were detected in some countries in Latin America, Africa, and Asia. The countries and regions where the band is to the right of zero in both graphs, those are the countries: Peru, Bolivia, Latin America, Sudan and Ghana in Africa, Indonesia, and the Philippines are the countries where inconsistencies were confirmed. I am not going into the details, but I hope you can refer to the published papers. The second approach focused on the inconsistency of reported values in bilateral trade by using trade statistics on the exporter side and the importer side. Often, it's noted that the mercury trade is not properly reported, but this is a method that took advantage of the improperness. Analysis detected inconsistencies between reported values in several countries and regions, including countries where fieldwork and other previous research indicated some inappropriate trade practice. In addition to the papers I have shown you, we have such data. For example, gold production, mercury use, and mercury emissions from ASGM. This is the review paper. These papers have already been published. If you are interested, please contact us. Mercury, which once made mankind a dream of usefulness and mysteriousness, seems to raise questions about the way mankind interacts with things and technology, including the nightmares that continues to this day. Thank you very much for your attention.
Thank you very much, Dr. Nakajima. As for questions, please use the Q&A function on Zoom. You can post your questions either in Japanese or in English. You can submit the questions anytime. Now moving on to the third lecture, distribution of atmospheric mercury concentration observed at artisanal small-scale gold mining area. Dr. Nakazawa Koyomi from Toyama Prefecture University is going to give us a talk. Nakazawa-san, the floor is yours. Can you see my screen? Let me get started. Yes, please do. So I would like to talk about evaluation of distribution of atmospheric mercury concentration observed at artisanal small-scale gold mining area by using passive sampling. I am Nakazawa from Toyama Prefecture University, and I have a joint researcher. So by way of introduction, in 2017, in August, the Minamata Convention went into force. As you can see, this is looking at mercury emissions from various sectors. Number one is ASGM, accounting for 38%, and that's followed by fossil fuel burning and other sector emissions. So number one is ASGM, and this small-scale gold mining, as you can see, this is engaged by 80 to 100 million people worldwide, and they do that for living. So this is the current statistics. In the Minamata Convention, the wording is as follows: parties shall take steps to reduce and, where feasible, eliminate the use of mercury and mercury compounds. And this is in consideration of impoverished families who rely upon ASGM for living. So the expression didn't go far enough. So I'd like to talk about atmospheric mercury concentration. Hg0, this represents atmospheric concentration of mercury. And in not contaminated areas, that is background concentration, this is usually 1 to 1.5 nanogram per cubic meters. And in the refining areas of ASGM, momentarily 100,000 to 1 million nanogram per cubic meter of concentration is reported. And this is reported by OSHA in the United States. And the permissible exposure limit, or PEL, is being shown. And momentarily, the concentration which goes even higher than that is being reported. This means that mercury poisoning can be considered as the world's largest environmental industrial accident. And because of that, communities around can be also polluted. And this is related to poverty. So all of the family members are engaging with extracting and refining the gold using mercury. So mercury pollution is causing deaths, not just among adults, but also among children. So this has been reported. So this is how gold is being refined at the ASGM. As you can see from these photos, and this is just one method, but as you can see, gold ore is being extracted and collected, and it's crushed into pieces like sand. And these fine particles or sandy gold ore are mixed with water and mercury. And then those kind of drums are being used to create the mixture. And the mercury is already used in this process. And we are measuring the mercury in this step of the process, and it's detected already. And then it's refined this way. And then eventually the gold shop where you can exchange gold for money, at this place, the mercury is removed to produce their gold. And as you can see, this kind of a bean-like gold is extracted eventually, and this is being sold in the gold shop. And then in the steps number 3 and 4, mercury is used, and mercury is detected at high concentration. And then so far, we have tried and measure atmospheric mercury in many different ways. For instance, this kind of a portable mercury concentration detector, we used it to measure the mercury concentration in the atmosphere, or we may use this kind of a pump using as a power to measure the mercury in the atmosphere, as well as the passive samplers. So we use the passive samplers also to measure the concentration. And this is just one example. In the gold shop, acetylene burner is being used to evaporate mercury. And on the horizontal axis, we have time. On the vertical axis, we have the concentration. 1.5 nanogram per cubic meter is the background concentration, meaning that if you look at this unit itself represents very high concentration. And this is how the concentration changed. And this is the burning time. As you can see, 2 milligram per cubic meter of a very high concentration of mercury is being detected. And in gold shop, other gold shop, we did the measurement, and from the burning site, what is the decay as you go far away from this side of the burning? And then on the vertical axis, we have the concentration. If it is the burning table or below that, it's very, very high. And then if you move away, you see the decay, but still the concentration is quite high. So in terms of the health impact of the mercury exposure, what are the important routes of exposure? When you think about the human health risk, you have to think about the dermal and the ingestion, that is the oral route, and also inhalation route because of the breathing. These are the three major exposure routes that can be considered. And among those three, for mercury, what's important is intake or injection, or oral intake, or inhalation. So these are the very important exposure routes for mercury. And if we are to focus on inhalation, as we breathe, we inhale and we exhale. And the issue is, when it comes to mercury vapor, it doesn't have color, it doesn't have smell. So even if it's in massive amount, you can't realize it. If you have smell or if you have the color, you'll be able to recognize it. But then with mercury, you can't do that, meaning that people are not very much aware of the risk of mercury. That's why it's very difficult to understand what is the actual situation. And there is a concern of the human health risk coming from the inhalation exposure to mercury. So how can we measure atmospheric mercury? There is an active sampling method and passive sampling method. Active sampling method meaning we use the pump and measure the mercury in the atmosphere, but then you need to have quite a large equipment. And then you need to plug in the equipment into the power source. So you need to have commercial power supply for such active sampling. And yes, that is the major way. So because of that, this method is relatively expensive. So that can be an issue. Therefore, in one site, we can measure the concentration in one representative point, but then the horizontal area-wise distribution cannot really be easily measured with this active sampling method. So that is a disadvantage. And active sampling method has been the major method to use. That's why the atmospheric mercury concentration measurement has never been very easy. So we have not been accumulating the knowledge there, especially at ASGM. What is the distribution? What about the risk coming from the inhalation exposure? Such discussion has not been taken so much. And on the other hand, when it comes to passive sampling method, this does not require any power or commercial power, so it's easy to use. So that is a characteristic of this passive sampling method. Because it's easier to use, it can be used in different points of the site. So that way you can see the spatial distribution. So we developed such passive sampling method to measure mercury because of these advantages of the passive sampling method. So I'd like to show you the passive sampler that we have developed. And this is a kit, and it's portable. And as you can see, we have a kind of a column, and a 30 nanometer gold-coated quartz filter is being used. And in order to avoid the effect of the wind, we have the diffuser plate. And then it looks like this big in hand. And then we have the rain shelter. And then it's portable. When you move it around, you put it in a sealed plastic bag. And it's quite handy, a small one. So you can move it around, and it's portable. And with the fund given by the Ministry of the Environment, we did the research to calculate the sampling rate through the exposure testing. And using the sampling rate, we are able to measure the concentration in the environment. And then a C represents the environmental concentration. And we actually did the measurement with this formula. Let me show you some results.
So this is in Indonesia. And this is Palu City in Indonesia. And this is 2 kilometers. And this is a very small town. The population is about 400,000 people. So And around here, this area is the suburbs of this city. So there's a suburb, and very close, there is a gold shop for refining works. This is called Poboya, and there is an airport here. So this is a big city. So these are the photographs, and this is an aerial photo, and there's a bay goal here, and there are houses here. So the city is spread around here, and this is the city, and this is one of my students and also a local student, and they are setting up the passive sampler. And this is a gold shop for refining. It says, "We will buy gold." And in front of this place, children are playing like this. That's the situation of this city. The result is here, March 2023. COVID-19 is somewhat subsiding, and that was when we conducted this research. This is a map, and you can see the numbers. This is nanogram per square meters, and this is 24 hours average. And this is the Poboya gold refining area, so nanogram per cubic meters. And this is 496 nanogram per cubic meter, and this is 98, this is 23. And in the suburbs, you can see close to the gold mine refining area, you can see the numbers are higher. And as you go away from this area, the concentration becomes lower. Around 2010, we were using a passive sampler to conduct this survey as well, so I can show you the comparison. This is 2023 March, and this is from 2010 to 2012. And we separated the areas, and this is the refining works area gold shop, 9,172. This is 524 and 141. So farther you go away, there is a reduction of the concentration. Comparison between 2023 and 2010, the concentration is very high in 2010, and 2023 is lower. That was the tendency. This might be the effect of Minamata Convention. We haven't done the verification, so we are not sure. But as long as we were there to conduct this research, around this time, this ASGM business was very prosperous. But here in March 2023, there was less operation of ASGM. So I think overall ASGM is being reduced. That was what we have confirmed, and we would like to verify the situation going forward as well. The last one is the risk evaluation. This is HQ. This is the hazard quotient, and this is the formula EC divided by RFC. RFC is here, and we have this US EPA iris to have this reference value. So I used it. So I went to the site and we checked the note. So EC is very important. The accuracy of EC is very, very important for the risk analysis. Because people move around, they don't stay in the same place 24 hours. So for example, during the working hours, in 8 hours, they are sometimes in a concentrated area. So we use this kind of formula, and the actual situation is reflected on the formula. I'd like to continue. I'm running out of time. So this is one of the results. We used some towns for the measurement, and after the analysis, we have calculated the HQ, hazard quotient. We have a paper here. If you are interested, could you please read the paper? In the end, we used this passive approach, and also we conducted research on site to analyze the situation. So this is a passive sampler. It's a very small one. So for example, you can use EMS to send at this equipment so the local people can set it up, and then we can conduct risk analysis, and also we can conduct interviews about people who assess the risks, and also they can send it back to Japan so that we can use the filters to analyze, and also we can have a package of the on-site observation and risk analysis to check the mercury concentration in the atmosphere. As for the atmospheric concentration, we didn't have so much knowledge before, but by using this kind of kit, going forward, we can analyze and also manage mercury. Thank you very much.
Thank you very much, Dr. Nakazawa. Now we are going to have the panel discussion, including the Q&A. The moderator is the Jiro Koyama, the program officer from ERCA. And the panelists are Professor Takaoka, Dr. Nakajima, and also Dr. Nakazawa. Now I would like to give the floor over to the moderator, Koyama-san. I'm the program officer, Koyama, in charge of this environmental research promotion fund. So first, I'd like to take questions to the panelists that are submitted by the audience. If you have any questions, please use the Q&A function, and if possible, please write down your name when asking a question. And as for the questions in English, you can submit those questions to the Q&A function, and we will translate those questions and ask the questions to the panelists, and we'll get the answers. First, the question to Dr. Takaoka. HGS, the storage method was explained. What kind of facilities are going to be used for the storage? What kind of a treatment are you thinking of in such waste facilities? Thank you very much for your question. I actually skipped some of those explanations because I was running out of time. So in terms of a sulfur reaction with mercury, the industrial waste treatment facilities are what are being assumed for using the sulfur for the reaction with sulfur with mercury. And then, for instance, the mills are to be used, like vibration mill and others, for the reaction with the sulfur. And then afterwards, the managed final waste sites will dispose of these solidified mercury wastes. That's all from me. Thank you.
So this is for Professor Takaoka. Another one, cycle of mercury in the atmosphere. For example, distribution, movement, and also falling down on the grower. What's the situation? And is this related to globalization, global warming? Yes, thank you very much. I was talking about mercury cycle, showing the picture. And that's a static situation and the distribution. Yes, we suppose there is an impact of global warming. So up to 2050, we'll have to consider the impact of global warming for the calculation. Up to 2050, the impact of global warming, it's not shown right now so far. However, when it comes to 2100, the year 2100, the effect is going to be different. Thank you.
Next is a question to Dr. Nakajima. In order to be consistent with 1.5 degrees Celsius, the biomass power generation is going to go up. And the mercury usage will start increasing from 2040 onwards. So what is the relationship between biomass, power generation, and mercury usage? Can you tell us more about it? Yes, I'd like to explain that to you. So in our estimation, and this is just a rough explanation, emission factor is being used, and also the activity level is also used. And then as for the emission factor, UNEP Global Mercury Assessment, GMA 2018 is being used. And this is for each region. And then we also look at the efficacy of reduction or removal. And in this GMA report, compared to fossil fuel power generation, biomass power generation does not have the removal measures, meaning that emission factors are quite high. And because of that, the estimation from the coal-fired power plant generation to biomass power generation, the tendency is to go up in terms of the usage of mercury. But I'm not saying that biomass power generation is bad. We have to look at what is the input into the biomass power generation and what is the facility being used for biomass power generation. There are different methods for biomass power generation. Depending on the methods, the emission of mercury, is it going to be different? The raw material, I think, what's the important factor is the removal ability of the emission in the facility. And Professor Takaoka is collecting such information, so you can please probably add some comments. And also the raw material, how much mercury is being contained in the raw material is important. And also measures may be taken to reduce the mercury contained in the raw material, and that way emissions that can be reduced. But then that is not included in our estimation this time around. Professor Takaoka, would you like to add anything? Mercury is in the atmosphere. So the trees may have adsorption of mercury on the surface, on the skin of the trees. And also discarded construction materials may have some paints that may contain mercury. Therefore, the raw material can change the mercury emission from the biomass power generation. As Dr. Nakajima said, what kind of the emission removal treatment is being done, and that can change the removal amount of mercury. So this is going to be an important point. Thank you.
So to Professor Nakazawa, part of the mercury that's emitted in the atmosphere, is it going to be organic mercury? And to what extent it's going to be organic? And what is the factor to promote making it organic? So more than 95% is HGS. This is gas, HC0. And the rest is mercury that's 2 variant. And also mercury that is attached to particles. I don't think it's going to make any organic mercury, but so far, what we are discussing is H0G0. This is gasified, and also a mercury that is 2-valent, bivalent mercury. Thank you. In Palu, Indonesia, there has been an improving trend. Is this the trend overall for Indonesia? And what about other areas in Indonesia? ASGM, is it still rampant across different areas of Indonesia? This improvement trend, the reduction in concentrations, whether this is an overall trend in Indonesia or not, we don't know. We have to measure in areas where we had a measurement in the past, unless otherwise we can't compare. And in other areas, we actually did the measurement in some of these other areas. And the local people say that they are not using mercury, those ASGM
engaging people. But still, if we measure it, mercury concentration still may be quite high. So we have to continue to collect the data across many different areas. That's going to be important.
Thank you very much.
海外からの質問が一つ来ており。
There is one from an international audience. So what is the alternative for the use? Instead of mercury, can we use something different? And how effective are they? That's the question. So probably Professor Takaoka, yes. Yes, there are so many applications of mercury, for example, for thermometer and also blood pressure gauge, but they are phased out and they have alternatives for different thermometer and also blood pressure gauge using electronics. So there is a change, and also fluorescent light. In terms of the principle, they have to use mercury, but lighting equipment, or they can shift from fluorescent light to LED light. So it's possible for us to use different alternatives. Well, if there is no regulation, for example, something traditional, for example, red color, for example, traditional red color, it's possible for you to use mercury because it's allowed. That's a cultural thing. So, well, there are alternatives, but for some applications, there's no application.
So the next one is going to be the last question to Dr. Nakajima. In your scenario, mercury emissions by ASGM are going to go down quite rapidly in ASEAN countries, but in the South America as well as in Africa, the declining speed is going to be very slow. Why? Well, this is just a scenario, and this comes from the scenario. When we set up the scenario, as the basis of the scenario, well, the reason for that slow speed of ASGM reduction in those other regions is because when we set up different scenarios, we have some judgment criteria. One is the Minamata Convention party or not, that country is the party, or is this country has a national action plan. So these are the basis of the assumptions of the scenarios. And upon this basis, we are setting up the scenarios in terms of the speed of the ASGM activity reduction. And because of that, in Africa and in Latin American countries, we think or we estimate the slower reduction of ASGM activities. All the details are provided in the paper, and all of the assumption data is being opened in the paper. So please refer to that. Thank you.
So now we'd like to start the discussion. So in your presentation, Professor Takaoka, because of the atmospheric mercury, of course, we have to actively reduce the mercury. I understand that. But right now, do you have any reduction methods that's effective right now? Could you please introduce us? And also, the reduced mercury can be stored for a long time. Is that correct? Yes, thank you for the question. About the reduction method, well, today, Dr. Nakajima said that, well, ASGM was mentioned by Dr. Nakajima as well. So the atmospheric concentration is very important, and to prevent health risk hazard, and how to recover, collect mercury is very important as well. And the others, for example, from the source, well, the sources could be some industries. And according to our estimate, if we can use the best technology available, we can reduce the mercury concentration. So even with the current best available technology, we can reduce mercury drastically. So the rest is to what extent we are going to use what. And as Dr. Nakajima mentioned, in many cases, climate change, climate actions, and also we have co-benefit with climate actions. And there is a discussion about how much burden it might have, but it should be very effective in terms of co-benefit. And after recovery, according to the concentration, we'll have to think about how to dispose of it or how to manage it. If the ppm level is very low, it should be very difficult and expensive to recover them. So for higher concentration, we can recover, and for lower concentration, we can dispose of it after processing. Thank you. Passivation. Thank you. So according to your explanation right now, other than ASGM, we can expect some processing or disposal management at the source. But if the source is ASGM, right now, I understand there are not so many efforts or measures taken. And Dr. Nakajima was talking about retort to recover mercury and also cyanization to reduce emission of mercury. So those technologies, are they already used in ASGM?
Thank you for that question. So retorts or cyanization, these methods are being introduced gradually at ASGM sites. But each method has some related implications or problems. What about the retort, the collection, cyanization? We need to have a cyan. So if you think about these methods, sometimes we need to address some side effects of those methods at the same time.
So we were talking about ASGM. In your presentation, Dr. Nakazawa talked about mercury measurement using passive sampler, Professor Nakazawa. So what about the application of the passive samplers in the local areas? Are they using more passive samplers? As for the paper that explains passive samplers, we see them, we read them often, and we have reports about passive samplers as well. So going forward, I believe there will be an increasing number of passive samplers, many different types as well. Thank you very much. As Professor Takaoka says, monitoring is very important to check the effectiveness. And so passive or active samplers for monitoring should be more and more important. So these passive samplers, going forward, there will be more different types of samplers, or do you think there will be only one type of sampler? I don't think there will be only one, well, unless something happens and everyone starts to use the only one type. But anyway, it's important for us to collect knowledge from different local areas. So I hope there will be different types of passive samplers. Thank you.
Thank you very much. So thank you for your cooperation. We were able to share a lot of knowledge about the mercury management. So during the lectures and during the discussions, we have been able to identify a variety of issues. And I think the mercury management in Asia as well as across the world, it is improving and the health damage is going to be reduced. That is our expectation. Thank you very much for your participation. Those people online and otherwise, we have not been able to address all all of the questions, please understand. And with this, we'd like to conclude the discussion time because of the time constraint. Thank you very much. Thank you very much, Project Officer Koyama, and the lecturers, Professor Takaoka, Dr. Nakajima, Dr. Nakazawa. Please give them a big round of applause. So with this, we would like to conclude ISAP 2023 reflections on the Minamata Convention on Mercury towards Mercury management in the Global South. Thank you very much for your taking part despite of your busy schedule. So after you go out of Zoom, there will be questionnaire survey. Please fill out the survey so that we can learn from this experience to make it even a better session. Thank you very much.